Hi students, this video is going to show you how to work each of the three types of kinetic energy problems. Ke equals 1/2 mv squared. The first type of the problem is just solving for kinetic energy. And in that problem type, it will be very simple because you will only have to just multiply straight across. For the second type of problem, you're going to be solving for mass. And so you're going to be given kinetic energy, you'll be given velocity, you'll have to isolate the mass. And to get it by itself, you're going to have to end up dividing both sides by 1/2 times v squared. The third type of problem that you're going to have is you're going to be solving for velocity. And you'll need to isolate the velocity and get it by itself. You'll be given the mass, you'll be given the kinetic energy, so you'll plug those in. But then to get velocity by itself, you will have to divide both sides by 1/2 times m. And in the end, you will end up taking square root of both sides in order to get rid of that squared. So let's go ahead and get started. If you can do these three sample type problems, you're going to do great on your test. All right, let's take a look at sample problem number 1. A baseball is pitched with a speed of 60 meters per second. If the baseball has a mass of 0.250 kilograms, what is its kinetic energy? All right, so this is the simplest type. We're solving for kinetic energy. I'm going to start by writing my formula. Now I'm going to write the formula plugged in. Mass, so I go up here and look for the mass. Right here, it has a mass of 0.254 kilograms multiplied by the velocity, right here, 60 meters per second, and that will need to be squared. All right, so now I'm ready to multiply this straight across. On your calculator, you're just going to need to remember to hit that x squared button after the 60. It is on our scientific calculators, it's like the fourth button up on the left side of the calculator. So I'm going to go ahead and find my calculator real quick. You can go ahead and be plugging it in yours to see if we get the same answer. Hey, a great way to practice these problems while I'm looking for my calculator, a great way to practice these problems is to pause the video when you have a blank screen, nothing showing but the sample problem, and try to work it yourself. And then, if you have trouble, go back and play the video so you can kind of figure out where you went wrong or what you needed to do next. Okay, I'm about to plug this into the calculator. I'm going to go ahead and multiply 0.5, because 1/2, of course, is a decimal, is 0.5, times 0.254 times 60, x square button, enter. And I get 457.2 joules. That's my final answer. There it is. Okay, sample problem 2. The greatest speed that a meteoroid can have and still be pulled down to Earth's surface is 70,000 meters per second. If a meteoroid traveling with this speed has a kinetic energy of 2.56 times 10 to the 13th joules, what is its mass? All right, so I'm going to start out by writing my formula. Probably the first thing I need to do here is determine what am I looking for? What do I need to solve for? And that can be shown here. What is its mass? So I know that I'm solving for mass. I'm going to end up needing mass by itself. I'm going to go ahead and plug in the values for kinetic energy. 2.56 times 10 to the 13th joules equals 1/2 times the mass, which is unknown, so that will remain. We need to keep it right there for now till we can isolate it. And then we're going to multiply this by 70,000 meters per second, and we're going to square it. All right, so I need to get the m by itself, so I'm going to go ahead and divide both sides by 1/2 times 70,000 meters per second squared. Not sure why I just put that. Okay, so on this side, of course, this cancels out. And now I need to plug into my calculator. And so I'm going to start with the top. And I'm going to use parentheses on this. And I'm going to go ahead and rewrite this just where you can see exactly how I'll need to enter this into the scientific calculator. I'll need to put parentheses at the top since it is in scientific notation, because I want to keep the 2.56 with the 10 by 13th and then divide the whole thing by 1/2 times 70,000 squared. So I'm going to use parentheses for that. Of course, I'll use that little up arrow button and 13. Close my parentheses. Divided by 0.5 times 70,000 squared. Close parentheses. And that's how you enter it into the calculator. That way the entire top is divided by the entire bottom. All right, so I'm going to go ahead and start. Open parentheses. 2.56 times 10, up arrow, 13. Close parentheses. Divided by, open parentheses, 0.5 times 70,000 x squared, close parentheses, and enter. And I get 10,448.98. Of course, those units are kilograms for my answer. All right, let's go ahead and go to I lost sample problem 2. All right, for sample problem number 3, a 725 kilogram automobile has a kinetic energy of 3.02 times 10 to the 5th joules as it travels along a highway. What is the car's speed? So this time we're solving for speed or velocity. Start out with my formula. Now I'm going to plug everything in. The kinetic energy, it tells me, is 3.02 times 10 to the 5th joules. The mass, 725 kilograms. And we're trying to solve for velocity. All right, so we're going to keep that velocity. We're going to keep that squared with it until the very end. We can get rid of that squared then. Okay, so now I need to rearrange it. So I'm going to divide this side and this side by 1/2 times 725 kilograms. course, it cancels on this side, leaving my v squared by itself. So v squared is equal to, and I'm going to put this, once again, I'm going to write this down now as I put it into the calculator so you'll know. All right, so open parentheses, we'll need 3.02 times 10 to the 5th divided by 0.5 times 725. And now I'm going to put that into my calculator. Open parentheses, 3.02 times 10 up arrow 5, close parentheses, divided by, open parentheses, 0.5 times 725, close parentheses, enter. And I get 833.1. And now the units at this time technically are meters squared per second squared. But you don't have to really worry about that, so I'm going to get rid of that, okay? I just wanted you to know it. Yes, there are units there, but once we take the square root, it's just going to leave velocity units, which is meters per second. So I need to get rid of the squared on the left side. In order to do that, I'm going to do the opposite, which is to take the square root, and I have to do that to both sides. That leaves me with v equals. Now to put this into my calculator, I need to use the second button and then the x squared button. Because right above the x squared, there is a little blue square root. And so that's what the second function allows me to do. It allows me to get to this one, or do the square root. So now I'm going to enter second x squared 833.1 and enter. And I get 28.9 meters per second. That's my final answer.